something tomorrow, which I'll also gladly do, but I figured that about these two talks, I want to mention some things which, well, I think are really worth being mentioned in a comment to the two talks that we heard before lunch. And so we have sort of a one-time privilege to give comments.
This is the rebuttal.
Yeah, this is the beginning of the rebuttal, because why wait till tomorrow? Just for these two talks. So, for your talk, Greg, I want to mention that I think you ran out of time and you didn't mention the following.
Completely ran out.
Right, but I'll try to compensate for this 5 minutes. So the point is, and I think this may answer part of Mariusz's question, is that consider this pair GK and look at this Greg's functor R S, what do we call it? RS gamma, is that what we call it, Greg? Or
No,
the
I
S.
didn't introduce it.
Yeah, I know. So this is the, so you were talking about derived functors of the functor gamma, and we want to take a specific derived functor, which was invented by you, where S is a specific dimension, okay?
Okay, and that's not the correct dimension. That's not the correct definition.
Yeah, okay, why not?
Because you need to choose a quartile subalgebra of K, which you haven't done.
Yeah, yeah. Okay, so let's put a T here.
Yeah.
Okay.
And then you have to tell people what S is.
Yeah, S is 1/2 of dimension of K minus dimension of T. And if you do this and go from something that I vaguely want to call highest weight modules, well, they're highest weight modules with respect to certain Borel, which somehow is, or parabolic. But if you do this, then it transforms highest weight modules to non-highest weight modules.
Not always.
Not always, yeah, but sometimes.
Possibly not.
Possibly, exactly. Possibly. And I think that this is very interesting thing in the construction, that Greg's functor provides a connection between category O or its extensions to GK modules by definition, because what this functor makes is whatever you put in here, it makes GK module out of it. But in many cases, these GK modules are not highest weight modules, and if you choose K appropriately, they sometimes for some appropriate choice of K, there aren't any GK modules which are highest weight modules. Well, except maybe the finite dimensional ones. And that's what we've been exploiting very much. And that's what gives you systematic constructions of GK modules, and that's what connects the two worlds. And in a recent paper with Vera, which Greg told you to read, but didn't even mention. So this latest paper with Vera shows that under certain conditions, when K is isomorphic to SL2, then this can be an equivalence of categories. And I kind of pride myself for insisting that we consider this question because in many, it is hard to nail down when this functor is an equivalence of categories. And Greg and I sat down, and so we discussed it at length, and we found a very nice case when K is the simplest possible subalgebra of G isomorphic to SL2. There is finitely many choices of such algebras, up to conjugacy, doesn't matter. And finally, we were able to nail down when this is an equivalence of categories, and I think that this
You have to tell me what the target category is. This
Yeah.
is meaningless
True, true.
to a general audience. That's
Sure.
my point.
Well, so it is a certain category. Well, in a very small time I can't do this, but it's a certain category of GK modules, which for certain choices of K are never highest weight modules, and still are equivalent to O-type category. And well, I think that this is like a first feature which people should be aware when they follow your suggestion to read linearly all papers, right? So that's my comment concerning Greg's
Yeah,
talk.
but if you read the papers backwards, isn't this the most recent of our papers?
Yeah, that's the most
Yeah, so just start backwards.
And concerning Vera's talk, I just wanted to draw a diagram because I think Vera gave herself very little time because she's the organizer. So she gave herself very little time, didn't have time to draw this diagram. Yeah, I have two comments in Vera's talk. So Vera. First comment is, indeed we did the Sokal filtration of this module. So Stirkus and I, we considered this module and we understood its Sokal filtration. But its radical filtration is still unknown and presents some sort of combinatorial challenge. Okay, and it's not the Sokal filtration. So what's known is that it's not the Sokal filtration, it's different, and it presents, again, some combinatorial challenge.
By saying the Sokal filtration is known, you mean that the associated graded object was described by you, right?
No, we
Because this-
described.
I know, I'm not an expert here in literature and whatever, but I was just listening carefully to what Vera was saying.
Yeah, she was
described
described.
it simply as associated graded.
Correct, but
Right.
we have described the actual Sokal filtration of which you take
it's
the
okay.
associated gradient. So
But here, your question is that, that for the radical filtration.
yeah, now for the radical.
Associated graded object is not known.
No, it's not.
I see, okay.
This is first comment. Second comment is that I want to draw a diagram of the categories that Vera was referring to before she got to Deline's category. So she started with this category int G, which was this very general category of integrable G modules. Then she had a category which she refused to name, but it's called, well, 10 tilde G. These were the modules which had this nice finite Levy length. So they were integrable, had finite Levy length of M and M dual. Okay, so this was this category that we discovered. And the point of this category is that it has very few simple objects, but the objects in it are huge because these Levy filtrations are finite, but have huge multiplicities, uncountable multiplicities of the composition factor. Then the next, this is where I asked her, how do you want to, which category are cutting down? So she was cutting down to this category TG. And this TG was the category with the large annihilator condition, which was imposed in addition to that. And this category consists now of finite length objects with finite X with the same simple objects as here. So this category has a zoo of simple objects which we don't understand. This category has few simple objects, but the objects are very large. This category has the same simple objects as here, but we sort of understand the extensions, they're finite dimensional. Then here, Vera considered the category of what I can denote here, int G H, which is H semi-simple. So H was a Cartan, H semi-simple modules with finite H multiplicities. This is the category which is semi-simple. So this is semi-simple. This, and the simple objects will be described by Ivan Dimitrov. So this has a different set of simple objects than these two. And the intersection has very few simple objects. Namely, if you intersect this with this, then it has already very few simple objects, and these are the simple submodules, simple subs of V tensor n separately, so no mixed tensor product, and V lower star tensor m separately. Okay? And of course, if you take the subcategory of TG, where you take pure tensors without mixing, that's certainly semi-simple. All the extensions come from mixed tensors. And so this is the picture that she had in mind and didn't have the time to draw, so I figured I want to draw it for her. And the last comment is that I want to mention that this category has a different description also, as the modules which are H semi-simple for all cartons. See, this is for a particular carton and has finite dimensional weight spaces. And these are semi-simple for all cartons, but are allowed to have infinite dimensional weight spaces. So we call this also absolute weight module. And I thought that since she gave herself very little time, but I can fill in. This is the diagram that you
Yes, the point is we have lunch and you're hunting
Yeah.
for your lunch.
Yeah. So thank you.
Because
That's all
we
I
don't,
want to
yeah,
say.
we don't have funding to provide lunch, so you have to go and hunt for lunch. And it might be difficult today. You might have to kill some parents.
On the way.
I'm sorry?
My understanding is that this intersection are not features.
So the point is, this is a graduation.